So today we're going to be looking at modeling with systems of linear equations in three variables. So here we go. Mark has $100,000 to invest. His financial consultant advises him to diversify his investments in three types of bonds: short-term, intermediate term, and long-term. The short-term bonds pay 4%, the intermediate term bonds pay 5%, the long-term bonds pay 6% simple interest. Remember, interest equals principal times rate times time. Mark wishes to realize a total annual income, so our time is 1 year, which is nice, we don't have to worry about the time, of 5.1% with equal amounts invested in short, this is going to be important, equal amounts invested in short and intermediate term bonds. How much should he invest in each type of bond? Now remember, we always look to this last part to kind of find our question. So that's how we're going to define our variables. So I'm going to let X equal the amount of money in short term, Y equal the money in the intermediate term bond, and Z be the money in the long-term bond. By the way, notice how the interest rate goes higher the longer your term is, and that's pretty common because you're basically tying up your money for a longer period of time, so usually you'll get a higher interest rate. Not that high right now. So he has $100,000 to invest, and he's putting it in these three different bonds. So we start with the first equation, which is the easiest. X plus Y plus Z equals 100,000. Then we're going to have an equation about our percentages. So the short-term bond pays 4% interest, so that's going to be 0.04x. And the intermediate 5%, so 0.05y. And then the long term is 6%, so 0.06z. And he wants this to actually become 5.1% of his total, so 0.051 of the total that he invests. So you probably want to, right off the bat, multiply 0.051 times 100,000, and if you do, you get 5,100. So I'm just going to cross that out and put 5,100 underneath it. Then the sentence here, he wants to put equal amounts invested in short and intermediate term bonds. So we're being told that X equals Y. So I'm going to write that as an equation, X minus Y equals 0. So the nice thing about that is it's already in just two variables. I'm going to clean up this middle equation to get rid of the decimal points. So if I move this 2 places, then I have to do one here too. So I'm going to get 4x plus 5y plus 6z equals 510,000. And I'm also going to be using this first equation, and I'm going to be using this equation. And I'm going to eliminate z. And hopefully you see why, because I already have an equation with just two variables. So I'm going to use that, and I need to eliminate z from this, and then I'll have a second equation. So I'm going to multiply this by a -6. So I get -6x minus 6y minus 6z equals -600,000. And when I combine it with the one above, I get -2x minus y, the z's cancel, equals -90,000. I'm going to multiply, I'm going to multiply by a -1 and make this 2x plus y equals a positive 90,000. So now I have this equation and this equation. So I'm going to do these over here. So I have x minus y equals 0, and 2x plus y, how convenient. So when I combine these, the y's cancel, and I get 3x equals 90,000, which means x equals 30,000. So that means that he should invest 30,000 in short term. Remember, he's doing the same amount in the media or the intermediate, 30,000 in the intermediate. And we had a total of 100,000, so that's going to leave 40,000 in long term. Okay, so that is how you would do a problem like that. So our next problem, a farmer has 1,200 acres of land on which he grows corn, wheat, and soybeans. It costs $45 per acre to grow corn, $60 to grow wheat, and $50 to grow soybeans. Because of market demand, the farmer will grow twice as many acres of wheat as of corn. He has allocated $63,750 for the cost of growing his crops. How many acres of each crop should he plant? So those are going to be our variables. So I'm going to let C equal acres of corn, W equal acres of wheat, and I'm going to let B equal acres of soybeans. All right, so we have a total of 1,200 acres. So we have C plus W plus B equals 1,200. We have one about our cost. So we have 45C plus 60W plus 50B, and he has a total of $63,750. And here's the next one. The farmer will grow twice as many acres of wheat as of corn. And let me caution you on this, because when people read this and they think twice as many acres of wheat as corn, they tend to write this down because it's the order that it's in. But think about what this would mean. If I grew 100 acres of corn, then I would be doing, if I did 100 acres of wheat, I would be multiplying that by 2 and doing 200 of corn, and that's the wrong way. So this is actually wrong, and it's the other way around. So C equals 2 times W, twice as many acres of wheat as of corn. So if I do 100 acres of corn, then I'm going to do, I wrote down the same thing. Okay. Yeah. Let's try this. W equals 2C. So if I do 100 acres of corn, then that means 200 acres of wheat. So I'm twice as many acres of wheat as corn. So you have to kind of be careful on that. So then I'm going to write this as W minus 2C equals 0. So that's going to be my third equation. So just like in the last problem, this is kind of nice that we have an equation in 2 variables. So then that means I'm going to take my first 2 equations. So I'm going to use these, and we're going to eliminate B. So I'm going to take my top equation and multiply by negative 50. So I get negative 50C minus 50W minus 50B equals, oh, I could have done that in my head, negative 60,000. And our other one. So then when I combine these and the B's drop out, I get negative 5C plus 10W equals 3,750. I'm going to combine that with my other equation that was W minus 2C equals 0. Okay, well, I'm going to write this as 10W minus 5C equals 3,750. And on this one, I'm going to multiply by a negative 10. So I get negative 10W plus 20C equals still 0. So we get 15C equals 3,750. And if we divide that by 15, we get C equals 250. So once we know that first one, so we need 250 acres of corn. And remember, however much corn we do, we're going to do twice as much wheat. So that's 500 acres of wheat. So that's a total of 750. We were doing 1,200 altogether. So that leaves over 450 acres of beans. Okay, so that's how you would do that problem. Okay, next, Nicole started a new diet that requires each meal to have 460 calories, 6 grams of fiber, and 11 grams of fat. The table shows the fiber, fat, and calorie content of one serving of each of 3 breakfast foods. How many servings of each food should Nicole eat to follow her diet? Okay, so notice that our variables are not going to be fiber, fat, and calories because it's how many servings of each food. So it's the toast, the cottage cheese, and the fruit. So I'm going to let T equal the servings of toast and C equal servings of cottage cheese, and F equals servings of fruit. Okay, so from there, so we have to have an equation that's about fiber, and we're going to have one that's about fat, and we're going to have one that's about calories. So she has a total of 460 calories. Well, 100 calories in each serving of toast, plus 120 calories in each serving of cottage cheese, plus 60 calories in each serving of fruit has to equal 460 calories. Then for the grams of fiber, so if we take, she wants a total of 6 grams of fiber. Well, she gets there's 2 grams of fiber in each serving of toast. There's not any cottage cheese, so we'll leave that off, plus 2 grams of fiber for each serving of fruit, and she has a total of 6 grams of fiber. And then for the fat, we have 1 gram of fat for each serving of toast, so 1 T or just T, and 5 for each serving of cottage cheese, and none for the fruit, and that total is 11. So I have my 3 equations. Now notice 2 of them have only 2 variables, but they're not the same variables. So I actually do this problem a little differently. First of all, I notice I can factor a 2 out of my second equation. I'm going to do that and have T plus F equals 3. And then I'm going to leave this one here, T plus 5C equals 11. What I'm going to do here is notice that I have a T in each one. So there's a kind of a trick that you can do on this problem. And I'm going to take this second equation and solve for F, and I get 3 minus T. Then I'm going to take the last equation and solve for C. So first of all, I have 5C equals 11 minus T, and I have to divide by 5, and yeah, I'm going to have fractions. So we get C equals 11/5 minus T over 5. So now what I'm going to do is I have a way to express F in terms of T, and a way to express C in terms of T. So I'm going to be plugging those in for the appropriate spot. So I'm going to have into my first equation. So I have 100T plus 120, and instead of C, I'm going to put into that 11/5 minus T over 5 plus 60, and instead of an F, I'm going to put 3 minus T equals 460. So notice I'm using substitution this time instead of elimination. So when I'm going to distribute. Actually, I could have left it without dividing each one because I see what's going to happen here. 5 goes into 120 24 times, so you're going to get 24, 24 times 11, let me do that. So we get 264 when we multiply that. And here, the 5 goes into 120 24 times, so I have minus 24T. Distribute here, we get plus 180 minus 60T equals 460. Then we're going to combine like terms. So we have 100 minus 24 minus 60. So we have 16T. And if you take 264 plus 180, you get 444. So that means 16T equals, and if we subtract that, what do you know? We get 16. So T equals 1. So 1 serving of toast. And we know that for the fruit, it's 3 minus T, so 3 minus 1 is 2. So 2 servings of fruit. And we know that if we plug in a 1 here, 11/5 minus 1/5 is 10/5, which equals 2. So 2 servings of cottage cheese. So notice how I did that problem a little differently because of what was given to me. You didn't have to do it that way, but that's the way that I chose to do that. So for the last example I'm going to do, an investor owns 3 stocks, A, B, and C. The closing prices of the stocks on 3 successive trading days are given in the table. Despite the volatility in the stock prices, the total value of the investor's stocks remained unchanged at $74,000 at the end of each of these 3 days. Okay, not very realistic actually, but they're making it easy on us. How many shares of each stock does the investor own? Okay, so this helps me find my variables. So I know I'm not talking about Monday, Tuesday, Wednesday as the variables, but it's stock A, stock B, stock C. So I'm going to let A equal the shares of stock A. B is the shares of stock B. And C is the shares of stock C. And you shouldn't just say let A equal stock A because it's specifically the number of shares of stock A. So kind of be careful on that. So we have these values. So we need an equation for Monday. So on Monday, we had $10 times the number of shares for stock A plus 25 times B plus 29 times C. The total value was $74,000. The next one we have 12 for each $12 times the number of shares for stock A plus 20B plus 32C, also equal to $74,000. And for the last one, 16A plus 15B plus 32C, also equal to $74,000. So here's my 3 equations with my 3 variables. I'm actually not going to solve this one. I'm going to figure that you guys could do that because you would take 2 equations, eliminate a variable. I probably would eliminate B since I'm dealing with 15, 20, 25. So I would probably take like equations 1 and 2, eliminate B, and then maybe take 2 and 3 and eliminate B, and then like what you know how to do. So, coming up with the equations really is the hardest part. So I'm going to end this video there, and you have some word problems that you will need to do for your assignment.